Welcome back. Problem 11-93. This problem is taken from chapter number 11, Energy Methods, and book name is Mechanics of Materials by Beer Johnston. It's its 6th edition. And the topic that we are covering is Castigliano theorem. So statement is for the beam and loading shown, determine the deflection at end C. Use E is 29 into 10 to the power 6 psi. So you can see this is a cantilever beam having fixed support at point A, and at point C we have 4 kips load, and at point B we have 8 kips load. So this is wide flange beam. This is, you can see, W14 by 30, a wide flange beam. So what, due to this loading, the beam will deflect like this. So we are going to find the deflection at point C, which is delta C or YC. So we will apply Castigliano theorem, and by using Castigliano theorem, which states that deflection with respect to any point, if you are using to find the deflection due to this force or this force, so you can find it by using the partial derivative of total strain energy with respect to that force. For example, if that force is Q, or if that force is P, so you can find that by using the partial derivative of total strain energy with respect to that force. We know that strain energy due to bending, which is equal to capital U, and that is equal to integral of m square over 2EI into dx. Clear? So what we are going to do is that we will find the moment equation for portion BC. I will write it portion BC, which is for x is greater or equal to 0 and less or equal to 2 feet, and we will find the moment for portion AB, where this x is greater or equal to 2 feet and less or equal to 8 feet. So what we will do is that, again, we know that if you take the partial derivative of total strain energy with respect to that force, which is that is Q, which will give you the deflection at that point, and we are going to find at point C. So deflection at point C will be equal to partial U or partial Q, and if you take the partial derivative of that total strain energy, so you will get 1 over EI, and that will be integral of M into partial M over partial Q into dx. So this will be the equation of deflection for the strain energy. So here you can see we will use this equation. For that we will need the moment, bending moment for portion BC as well as for portion AB. So what we will do is that we will find for portion BC. Clear? And what we are doing is that if we cut the beam in portion BC and let this distance is x and draw the free body diagram, so it will be like this. This is your point C, where 4 kips load is applied, and we will replace this force with Q. Let this Q is equal to 4 kips, and this distance is equal to x. So when you cut it, you will be having a shear force and you will be having a moment M. So we are interested to find this moment M. Okay. This is point, let this point is point O. So what we will do is that we will apply equation sum of all moment about point O is equal to 0, and taking the counterclockwise moment as positive. So about point O, the one moment is 4 into x, and this is producing clockwise, so it is negative, and the second reaction moment is M, which is also clockwise, that will be also negative. So I will write minus M minus Q times x. For time being we replace 4 with Q, so Q multiplied by x, Q into x is equal to 0. So it means that this moment is equal to minus Q times x. Okay, now we have this moment. So here we also need another term, that is implies that partial M over partial Q will be equal to minus x. So now you have this M as well as you have this term, so you can just put it in this. Okay, so what we are going to do is that we will find this term integral from 0 to 2 feet and m into partial m over partial q into dx. This will be equal to integral from 0 to 2 feet. M is equal to minus q times x, and this partial m over partial q is minus x into dx, which will give you minus qx square into dx. And if you integrate it again, so what we will do is that it will be equal to minus q integral of 0 to 2 feet, and it will be x square into dx, which gives you, if put q is equal to 4 kips, so that will be equal to minus 4 into x cube by 3, and limit will be from 0 to 2 feet. Clear? So that will be equal to minus 4 by 3 x cube 0 to 2 feet. So minus 4 divided by 3, and that is 2 cube minus 0 cube. So when you calculate it, it will be equal to 10.67 kips into cubic feet. Now we just only find this term, clear, for portion BC. What we will do is that we will find this the same thing for portion AB. For portion AB. So what we will do is that we will cut this beam anywhere this distance will be equal to x, clear, and we will draw the free body diagram. So let me draw it first. This is your point C, where you have 4 kips load, and that is taken as Q, clear. And at point B, let this your point B, where you have 8 kips load, clear. The distance between A to B to C is 2 feet, and total distance is taken as x. X is variable, clear. So when you cut it, you will be having a shear force V, and you will be having a moment. And what will be x is greater or equal to 2 feet and less or equal to 8 feet. Okay. Now we will find this moment equation by using sum of all moment about point 1 is equal to 0 and taking the counterclockwise moment as positive. So you can see about point 1 moment is this q into perpendicular distance is x. This is clockwise, so it will be negative. So I will write it minus q times x. The second moment is due to this load into perpendicular distance is this one, which is equal to x minus 2 feet. And this is also producing clockwise, so it will be negative. So I will write minus 8 into x minus 2. This distance is x minus 2 feet. Okay. And the third moment is this one, which is the reaction moment, and this is also clockwise. So minus m. Their sum must be equal to 0. So it means that this moment will be equal to minus 8 into x minus 2 minus q into x. That this is your equation number 2. Okay. Now we have the equation from limit from the limit was from x is greater than 2 and less than 8 feet. Okay. So 2 and 8. So it moment into partial m over partial q into dx. So again put it limit from 0 to 8. So plug in the value of m and delta m partial m over partial q. So m is minus 8 into x minus 2 minus q into x. This is the value of m, and delta m is minus x into dx. Put q is equal to 4 cubes, that is we have taken over here. So what we will get is this integral of 0 to 8, it will be minus 8 into x minus 2 minus 4x into minus x into dx. So when you multiply this minus with these both term, so I will write it, it will be equal to 8 into integral from, this is 2 to 8, not 0 to 8, 2 to 8, 2 to 8, and that will be equal to x square minus 2x into dx, and this term will be minus 4 into integral from 0 to 2 to 8, and this term will be x square into dx. Now this 8 into x square, so 8x square, 8 into integral of 2 to 8 dx minus 16 into integral of 2 to 8 dx and minus 4 into integral 2 to 8x square dx. So this will give us 8x cube by 3 and limit from 2 to 8 minus 16 into x square, here there is x square over 2 and in limit will be 0 to 8 minus 4x cube over 3 and limit will be 0 to 2 to 8. So when you solve this, this will, after taking the limit, this term will give you 4096 divided by 3 minus these terms will give, all these terms will give, I will write it, you can also check it later, 1024 divided by 2 plus 64 over 2 plus 2048 by 3 minus 32 divided by 3. So this will give us the term, this integral from 2 to 8 m into partial m over partial q into dx will give us 1536 kb into cubic feet. Now what we do is that we will find deflection at point C. So deflection at C is equal to 1 over EI into integral from 0 to 2 m partial m over partial q into dx plus 0 to 8 m into partial m over partial q into dx. It will be sum of both these. So just put the value 1 over EI. Again this term we can see that this term is equal to 10.67. So 10.67 plus this term which we have find out here, you can see this is, which is 1536. Clear? This is equal to deflection at point C. So we have E is given as 29 into 10 raised to power 3. Let me check, 29 into 10 raised to power 3 KSI. So we do not have I. So what we will do is that again you have to go to the property table of this rolled steel, and here you can see that you have to search for W 14 by 30, that is given. So here you can see I is 291 inch power 4. So I will write the value 291 inch power 4. Okay, so these two terms having units kept into cubic feet. So what we will do is that this is inch power 4. So we will find this EI. So EI is 29 into 10 raised to power 3 KSI, clear, and it is multiplied with 291 inch power 4. That will give you 8.439 into 10 raised to power 6 kip into inch square. We know that 1 feet is equal to 12 inch. So 1 inch is equal to 1 over 12 feet. So it is square. So 1 inch square is equal to 1 over 12 square into square feet. Okay. So again, we will multiply this 8.439 into 10 raised to power 6 with this value of 1 over 12 into 1 over 12 square. So you will get the value in 58.604 into 10 raised to power 3 kips into square feet. Now these are also into kips into cubic feet, and this is kip into feet square. So what we will do is that YC is equal to 10.67 plus 1536 having unit kip into cubic feet, and EI is 58.604 into 10 raised to power 3 kip into feet square. So at the end what we will get is that we will get this deflection at point C will be equal to 0.0264 feet, and we know that 1 feet is 12 inch. So if you multiply it with 12, 1 feet is equal to 12 inch. So you will get the value is 0.317 inch YC, which is 0.371 inch, and this deflection will be downward. And this is the answer of our this part. So I will conclude it. We have find the deflection of this point C at point C by using Castigliano theorem, which state that the deflection can at any point can be obtained by taking the partial derivative of total strain energy with respect to that force. So here we take this Q at point C is equal to Q, which is 4 kips, and we applied this equation in order to get our required deflection. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it and don't forget to press the bell icon so that you can get notification about my latest videos. If you have any question, you can ask me in comment section. Thank you for watching.